Hi everyone, welcome back to our channel. In this video, we are going to learn about mutually exclusive events in probability. So what is mutually exclusive events? The events that can't happen at the same time. For example, if you throw a dice, getting an 1 and getting 6, they cannot happen at the same time. You can either get 1 or 6, not together. So these events are called mutually exclusive events. If you look at another example, you are going to a school. What's the probability that you will be late? Late is one event, or not late is the another event. So both cannot happen at the same time. So these are the examples for mutually exclusive events. One of the facts about mutually exclusive events is probabilities add up to 1. If you look at the dice example, what's the probability of getting a 1? 1 over 6. What's the probability of getting 2? 1 over 6. And what's the probability of getting 6 is 1 over 6. Getting 1, getting 2, getting 3, getting 4, getting 5, these are mutually exclusive events. You cannot have both of or two or more than two events happening at the same time. So if you add all the probabilities, then it's going to be 1, right? If you look at the other example, like going to school late, so probability of late probably 0.2, so probability of not late should be 0.8. So the one event, so probability of not late is always 1 minus probability of late. So this equation is very important when it comes to mutually exclusive events. Let's look at an example. A spinner has 3 sections, colored pink, blue, and green. So let me draw a spinner, pink, blue, green. The probability it lands on pink is 0.8. If the probability it lands on blue is half the probability it lands on green, find the probability it lands on green. So probability of landing on pink is 0.8, but we don't know the probability of landing on green or blue. But they have said landing on blue is half the probability it lands on green. So if the probability of landing on blue is, let's say, P, then the probability of it lands on green must be 2P, 2 times the probability of P, right? Now, if you remember the rule, the probabilities add up to 1. So 0.1 plus 2P plus P must be equal to 1. If you simplify this one, 0.1 plus 3P equal 1. This can go other side. So 3P equals 0.9. So P equals 0.3. So P equals 0.3 means landing on blue is 0.3. So landing on green is 0.6. So find the probability it lands on green, which is 0.6. Let's look at another example. One counter is selected from a box containing blue, green, and red counters. So there is a box where you have so many counters, right? We don't know how many each, but some of them are red, some of them are blue, and some of them are green. We don't know how many of them, but they have given you some information. For example, the probability that its blue counter is 0.5, and the probability it is green counter is 0.4. So probability of blue is 0.5. Probability of green is 0.4. So let's say you are picking one from this box. The probability that will be blue is 0.5, which means half of the counter, we don't know how many, but half of the counter in this box must be blue. Half blue. And probability of green is 0.4. So now you know probability of red must be 0.1 because they add up to 1. They say if there are 4 red counters in the box, how many counters are there altogether? So 0.1 is 10%, right? So there are 4 counters belongs to red. And probability of getting red is 0.1, mean 1/10, which means there must be 40 counters, right? If you have 40 counters and 4 of them are red, the probability of getting red is 4 over 40, which is 1 over 10, which is 0.1. So we have used this last information to find the total number of counters, which is 40. And we already know, since the probability of getting a blue is half, then half of the counters, which is 20, must be blue. So we have 20 already gone for blue, 4 is already for red. So out of 40, if you take 24 out, 16 of them is going to be red. So this is the distribution of the counter. 20 blue counters, 16 green counters, and 4 red counters. Thank you for watching this video. In the next video, we will learn about listing and outcomes.